So you need to do a cost equation to take the derivative. So the cost equation would be 40,000 y plus, since this is x, it would be 30,000 times x. Okay, there's two formulas, so I need to get rid of the y. So this is going to be 20 minus x. So using this Pythagorean theorem, I get rid of the y. And you substitute into this formula. Take the derivative, set it equal to 0, and solve for x. That's how you would find x and y. Okay, so another problem that you should know how to do is this homework problem, which was the optimization 5.1 part 2 number 18. So it says the swimmer is at a point 500 meters from the closest point on a straight shoreline. So here's the swimmer. Okay, here's the shoreline. So she is 500 meters from there. She needs to reach a cottage located, so here's the cottage, 1,800 miles downshore from the closest point. If she swims, okay, so she's going to swim at 4 meters per second. She's going to swim at 4 meters per second, and she's going to walk at 6 meters per second. How far from the cottage should she come ashore so to arrive at the cottage shortest amount of time? Okay, so she wants to arrive here, which we're going to call x. So what we need to do, since we want to arrive at the shortest amount of time, we need to optimize or take the derivative of time. And time, since the distance equals the rate times time is going to be the distance over the rate. Okay, so you're going to have two distance when she walks and when she runs. Okay, so the time is going to be her walking distance and her swimming distance and her walking distance. So we know that from here to here is 18. So this part of the distance that she's going to walk is going to be 1,800 minus x. Okay. We don't know how much she's going to swim, but we can find it using the Pythagorean theorem. So x squared plus 500 is equal to how much she's going to walk or swim. It's going to go equal to how much she wants to swim. So she's going to swim x squared. Okay, so she's going to swim x squared plus 250,000. That is her distance. So her time is going to be her swimming. So her distance that she's going to swim is x squared plus 250,000 over her rate. So she can swim at 4 meters plus the distance she's going to walk over the rate that she's going to walk, which is 6. Okay, so I can rewrite this as 1/4 x squared to the 1/2 100 minus 1/6 x. Okay, so taking the derivative of time, we're going to have 1/4 times 1/2. Everything on the inside stays the same, to the negative 1/2. Okay, so it's going to be times the derivative of the inside. Derivative of 300 is 0 minus 1/6. So we're going to set that equal to 0. So my 2's are going to cancel. I'm going to have 1 over, or x over 4, square root of x squared squared both sides. So we get 9/4 x squared equal to x squared. So subtract 1. Okay, so we're subtracting. So we need a common denominator of 4. So that would be 5/4 x squared equals, so x is 447.213 meters. Okay, so we have to go back and read the question. Okay, so we got x to be, so x is 447.213, and it says, how far from the cottage should she come ashore as to arrive at the cottage in the shortest amount of time? So this is her time, so it's going to be 18, or her distance, 1800 minus 447.213, and that distance is 352.786 meters.